So let's say you were asked to figure out in this balance mobile the weight of one of these squares. You would know a few things, namely that this would be 1 pound, the heart is 4, and the triangle is also worth 1. Sorry, not triangle, the rhombus, and then you've got another 4. So essentially all of this together is 10 pounds. And keep in mind there's a lot of different ways to solve this balance mobile. Over here you've got 4 pounds. And then you have a series of boxes for which you don't know their weight. And so as we begin to think about this problem, one thing we might want to do is recognize that we could basically sort of nullify this heart with maybe this heart, for example. And so I've essentially taken away or kind of counted out this 4, which means I've got to count this 4 out, which leaves me with only 6 pounds left. And so as I look at this, I could also then see that I have a square on both sides. And so this last square here and this square here are going to nullify each other, which essentially means that these two squares here have to be the same weight as the 6 pounds. So we know those have to be 6 each. And then by using some reasoning, we should be able to say, well, that means that this must be 3 and this must be 3. In other words, that 6 has to be split into 2 equal groups. So what does that have to do with solving an equation? Well, one thing we might do is rewrite our balance diagram kind of like this and say that when you have a balance diagram, it's really like a balance beam. The weights on both sides are equal. So if we had 3 squares over here, and I might be going off my screen just a little bit there, and I have a known 4 pounds, which was that heart, and then on the other side, I have another one of those unknown boxes. And then I basically had a grand total of 10 pounds. That's essentially what this problem is saying. And so when we talk about a variable, we're just simply saying we don't know the value. So we'll call each one of these x's. And then we've got some unknown weights and then some known weights. So if we were to write an equation with the left-hand side, it would look like this. There are 3 unknown boxes. So say just for the heck of it that it was 5 pounds each. That would be 15 pounds because 3 times 15. And then we've got plus 4 pounds. We know that much. And our expression on the right-hand side for all the weight would be x plus 10. And we are being told that those two quantities are the same weight, the same balance. That's what it means to be equal. And so as we begin to look at this, the first move that we might make in solving this, much like we did on the balance mobile, is to essentially say, well, you've got 4 pounds here, so let's take those 4 pounds away. Let's lift those off of our balance beam so that they're no longer there. And then I would, of course, have to take away 4 pounds from this side. And if I did that, if I kind of grabbed those things and just simply pulled them away, then now I would need to have basically no weight on the left-hand side, but now there would be 6 pounds on this side. And so we're getting a little bit closer. And then we might say, well, actually you've got, this block here and this block here, and those are the same weight, so why don't we just, take those off or subtract those away? And that would pull them off. Oops, I don't want to do that. That would pull them away. Oh, I can't remove the one block right now very easily, can I? So pull that away, pull that away, pull that away. Oh, that poor X, it just got dismembered. And then we'll pull all of this away. And that essentially leaves me with 2 blocks equals 6 pounds. So let's walk back through what we just did and make sense of what we did algebraically. So just as a reminder, I'll move all those things back into place. What we did first was to go ahead and look at our common weights, which were 4 pounds and 10 pounds. And we said that we could subtract 4 pounds from each side. So that's what we're going to do here. We're going to subtract 4 pounds from each side. And I'm picking 4 strategically because it's the additive inverse. So when I subtract 4, that's going to leave me with 3 boxes. So again, before we just simply pulled this away. And on the other side, when we subtract 4 from the known 10 pounds, that leaves us with only 6 pounds. And so we would go ahead and go through here and erase that and now say, okay, you've got, 6 pounds here. But our weights are still equal because we took the same amount from each side. So the key was here, the additive inverse. And now we're sitting here looking at, the fact that we have boxes on both sides, and then the next move we made was to pull these to subtract one of those off of each. So what we're going to go ahead and do is we're going to subtract x from both sides, or take away a box from both sides. That leaves us with 2x for the left-hand side, or 2 unknown box weights. But now we have a known weight on the other side, which is 6. And so we would take our diagram, we'd pull our x's away, pull those boxes out, get rid of them. Oh, they're just going to be difficult, aren't they? I only want the one, and it wants the whole thing. Anyway, well, you get the drift, right? So we essentially just take that one away, and then we take the other one away. And we can just kind of nullify those two. And so we're going to then divide by 2. As our final step to say that we have 2 boxes, what we know is 6 pounds, so that means each box must be exactly 3 pounds. So that's what it means to solve algebraically when you have variables on both sides. As you look here, you've got 3x and you've got x. So your goal essentially is to try to take things away and eventually have only unknown box weights on one side and only known numbers on the other side. So you might need to do a little bit of adding and subtracting from each side. You have to do it evenly in order to maintain balance, but eventually you'll get down to an equation that you could solve, usually by division.